Hey everyone, Roland this side. I hope you all are doing well. So let's say the problem of the day. So the problem number is 1301, number of path with maximum score. So basically you are given a square boards of character, basically a square board which contains character. You can move on board starting at bottom right marked square which character S. So basically we are given a 2D array of square, so it's basically n cross n, and the bottom right square is marked at character S. Okay, so if the bottom right is marked at character S, we need to reach the top left square marked at it. So we need to reach here. Starting from here, we need to reach here. Okay, and the rest of square are labeled at either numeric character 1 to 9 or with an obstacle X. So rest of character is either 1 to 9 and else X. Okay, in one move you can go up left or up left. Okay, so basically if we have this style of, if we are standing here, if we are standing here we can go either up, either left or up left, diagonally. So basically we have three ways to travel. Either we can go up, we can go left, or we can go up left. Okay, so only if there is no obstacle. So X is meant to be an obstacle here. We can only move there if X is not there. Okay, none of obstacle is there. Return a list of two integers. The first integer is the maximum sum of numeric character you can collect, and the second number is such path that you can take to get that maximum sum taken module of. Okay, so basically if in case there is no path we have to return 0 0. So basically what the question is saying, so we are given, for example, the first question is have something like e23 2x2 and 1 to s. So basically we have to, what we have to do, we have to start from here and we have to reach at end, and we have to return the maximum sub and number of ways to get that maximum sub. So for example we started from 2, we goes left, we go top, we go up. So basically we can't go top left because it's an obstacle there. So basically we can either move top or left. Okay, for example let's move left. So we go here, from here we go here, from here we go here, we go top left and then top. Okay, so we reach the end. Okay, and what is the score while reaching end? So 2 plus 1 plus 2, that is actually 5. Okay, so it's this path returns 5. And if we move the other way, so if we go this, then this, then this, then this, so it's written 2 plus 3 plus 2, that's actually 7. Okay, so this part returns 7. So what is the maximum score we can get while traversing from start to end? Okay, so the maximum score, let's call it max score. So maximum score we can get is 7. And number of ways to get that maximum score, so max path. So number of paths to get the maximum score is only one. We can get only one. For if we take another example, for example here it's e1 to 1x1 and 2 1s. Okay, so we have this. So if we go from here, this, so it's gonna return 4. And if we go from 1 to 1e, so it's also gonna return 4. So we got maximum score equal to 4 and maximum path to get that score we can get 2. We have two paths to get the 4. Okay, so we have two paths to get the 4, and we have the maximum score 4. So basically we have to return 4 comma 2 here, we have to return 7 comma 1 here. And in case if we see this example e11 triple x and 11s, we can't go, if we go left, then we can't go top. If we go diagonally, we can't go at diagonally. If we go top, we can't go at top. Okay, so we have to return 0. So at the end we are not going to reach the end, so we have to return 0 0. Okay, so I think that's the total question. So how we are going to apply? So first of all, if you see clearly, I think there is no such perfect algorithm. Instead of doing just DFS, iterating over recursive DFS, iterating and visiting all paths, exploring all paths. Okay. So what I'm going to do is, hold on. If we have, let's take that second example, second one. Okay, so what was that? So it's something like E1 to 1x1, E1 to 1x1, and 2 1s. Okay, so what we are going to, what we have to do. So how we are going to do the DFS is first to go top left and left. Okay, now from here what we can do, we can go to top left and left. Okay, from here we can go to top left and left, but it's the x here, so we can't really go there. Okay, so we have to, okay, so that's the possible paths. From here we can go here and here. We can't go here because it's an obstacle. From here we can go here, from here we can go here, from here we can go here. Okay, so that's the possible path. So basically a recursive kind of thing. So basically it's to go from here. So the recursion call here is the call gonna call it's to all three possibilities. So and then again this result gonna explore for all three possibilities. It doesn't have top or diagonal, so it gonna lead to left. And also this gonna explore its all possibilities. It doesn't have top, so it gonna explore left and left and diagonal. Okay, so that's the basically. So how next we are going to do what we are backtracking while doing the recursion. So for example, we have to return the score. Okay, so for example, what is the score we get while getting from, for example, we are at 1. Okay, so what is the score we are going to get reaching from, I mean, 1 to end? So it's basically 0. We are not going to get any score while reaching 1 to 0. Okay, so it's basically 0. So while backtracking, e gonna return last cell gonna return 0 to 1. Okay, and from 1 to 2, what it's going to, so what's the, I mean basically what is the score we are going to get if we backtrack from E to 1 and 1 to 2. Basically, what I'm saying, trying to say is, what is the score we are going to get while going to end from 2? Okay, from 2 we are going to get 1 and 0. Okay, so basically it basically means another way. So another way you can show the score we are going to get from 2 to 1 and 1 to end. So from 1 to end we are going to get 0 and 2 to 1 we are going to get 1. Okay, so it's basically gonna return 0 plus 1. What is the score we are going to get from 1 to 2? So it's, if we are going to get from 1 to 2, it's going to return 2. Okay, we are going to get 2 score. And what is the score we are going to get if we go and 2 to end? Okay, if we go 2 to end, we are going to get 0 plus 1, that is 1. So 1 plus 2. And again from starting, if we from start, what is the score we are going to get if we go to 1? Okay, we are going to get 1 point. And what is the score we are going to get if we go 1 to end? So 1 to end, we already backtracked it. It's 3 actually. So 3 plus 1. Okay. And we can write it 1 plus 3. And from starting, what the start index. So if we call for the start index, so that's gonna return 4. Okay. We have to call it in somewhere. So if we call from starting index, it's gonna return 4. Okay. So that's the score. And this also, this backtracking also gonna return, its cost actually 0. It cost the previous one plus the current one, that is 0 plus 1. It also gonna cost previous one plus current one. So previous one is 1 and current one is 2. It also gonna cost the previous one plus current one. So previous one is actually 3 and current one is actually 1. Okay. Previous, so 3 plus 1 4. Okay, so it's gonna return 4. So if we see, actually we got 2 4s here. So what we have to do, we have to, I mean, also backtrack on one more variable, which is number of paths. So how many ways we can get 0? There is only one way. In how many ways we can get the, I mean 1? It's only one way. In how many ways we can get 3? One way. In how many ways we can get 4? Only one way. Similarly, we have only one way to get these things. Okay. And how many ways we can get 4? So there are 2 ways to get 4. Okay, so at last it's gonna return 4 comma 2. Okay, 2 ways to get 4. And if you see, what I'm trying to say is, for example, we have something like, for example, this is node value 3. Let's take it to, for example, So it's basically written. So let's consider this as 3, 1, 3, 2, 2, all connected to end. Okay, so this is our end. So what it's basically gonna return? Okay, so it's gonna return 0 and one ways to get 0, and it gonna return the I mean gonna to get 3 we have one as it gonna return to get 3 we have one as one path. Okay, one ways to get 3. It also return one ways to get 1. It gonna return one ways to get 3. It gonna return one ways to get 2. It gonna return one ways to get 2. Okay, and what it returns, for example, it's connected to start. Okay, so it gonna return what? So here we have to select which is the maximum score. Okay, so maximum is 3. And how many ways we can get 3? We have 2 ways to get 3. Here select which is the maximum. Maximum is 3. And how many ways to get 3? That is 1. Okay, so 1 ways to get 3. From starting we have to select the maximum. Which is the maximum? So 3 is maximum. How many ways we can get 3? There is 3 ways. 2 from here and 1 from here. So that's actually we have actually 3 ways to get 3. Okay. We have actually 3 ways to get 3. So we have to return 3 comma 3. Okay, so that's why I'm trying to, that's what I'm trying to convince you, that we have to backtrack to variable what is the maximum score and number of ways to get the maximum score. Okay, the number of paths in which we are going to get that maximum score. So if we see so that's how we are going to do this. So in recursion, what we are going to do this is, what is the maximum score? Maximum score is basically max of left score. How we got from left, max of right score, and max of it is a diagonal score. Let's call it diagonal score. Okay, so we get maximum score from here, and how we are going to get calculate the path. Okay, so max path. So if max score equal to left score, okay, so that means we get the maximum score from left one. So we can do the number of paths. Okay, so max path plus equal to left path. Okay, what we got from left, and if max score equal to right score. Okay, what we are going to do is max path plus equal to right path. Okay, and similarly for diagonal one. So if max score equal to diagonal score, so max path plus equal to diagonal path. Okay, so if we got maximum score from both left and right, so we are going to end up adding both to, okay, left and right. For example, if here we got maximum score from left and right, for example, we have x and diagonal, so we got maximum score 3, we got maximum score 3 from both left and right, so we have to add the both of the number of ways, so number of ways to get from 2 here and here 1. Okay, so we have to add both. So that's how we are going to get the maximum score and maximum path. Okay, and how we are going to end up the writing up, how we are going to actually traverse and do the DFS, and how we are going to actually write write the solve DFS function. So it's something like okay, we have to return NPL. We are going to end up returning NPL. Let's from our DFS, and it's gonna take IMGS parameter and our what we call board. So in DFS, what we are going to do is, for example, if we are at E, okay, so if I mean board I and J equal to E, if we are at end, what we are going to doing is, if we are at end, if you see at end, we have one ways to get end from any adjacent cell, and there is zero score. So we are not end up using any extra. We are not end up using any, getting any extra score while traversing to end, okay, from its adjacent cell. So it's basically gonna return 0, 1. So we have to return 0, 1. There is one ways to get end, but we are not getting any extra score while getting to end from its just neighbor. Okay, called it adjacent. Okay, and next thing is if. So and another, so initialize the variables. For example, score from ups. I mean, what we called it here, left score, top score, up score. So left score equal to 0, up score equal to 0, and then diagonal score equal to 0. Number of ways to get that left score. So left path equal to 0, up path equal to 0, diagonal path equal to 0. Okay. So number of, and after that, after initializing this variable, what we are going to iterate over every, okay, iterate over every cell. So for example, what is the current cell? Okay, so cell is a character cell, which is B O B O A board I Z. Okay, and the value of cell is what we can do is current value, so we can call it current. So it's basically equal to cell. I mean, it's basically if. Okay, if yeah, cell is not equal to, hold on, if cell equal to s. Okay, I mean basically we are at the starting index, so at the starting we have 0 score, so end up starting we are not has any. So for example, we get 4 here, no, and again returning 4. Basically we are summing up 0 here because at the starting we doesn't have any score. Okay, so at least if cell is a start, so the current gonna become 0, else it gonna become, I mean, cell minus 0. So it's coming character. So for example, we got character 9. So character 9 minus character 0. So it's gonna end up returning 0. Okay. So that's the, I mean, naive way to, I mean, universal way to get the cell value current, I mean, extract the integer from the character. Okay. So now getting the cell value, what we are to traverse top, left, and top, bottom. Okay. So to traverse top, what we are going to do is first check if we have top. So for example, we are standing at the topmost layer, so we are standing at here, we have doesn't have top, so we can write a simple valid function, so that gonna check if is valid. Okay, so it gonna to what is top. Top is basically I minus 1. Okay, we are, I mean, decreasing the row I minus 1 j. Okay, so if I minus 1 and j is valid, so we are going to traverse top. Okay, to traverse top we are going to, I mean, call the top. So we have something like this. So if we go top, so we have to call them, I mean, we have to apply DFS here. Okay, and by applying DFS, what we are going to do is we are going to get score, I mean score till reaching end. Okay, uh, it gonna apply DFS, it gonna apply, or at the end either it gonna end up returning X. Okay, so if it's X, it also not valid. Either it end up returning X or it's end up returning what we call and. Okay, and so we got a score and path, number of ways to get that score from DFS of the top cell I minus 1 comma j. After that, the, I mean, we have to store it in score from left. So score left score equal to score left path. Number of ways to get that score is left path. We can is equal to path. And after that, if, I mean, if path is greater than 0, so what we are going to do is, if path is greater than 0, if path is greater than 0 means basically means we get a path to actually, I mean, go to end. Okay, we get a path to actually go to end. Either it gonna return 0. Okay, so if it's actually greater than 0, so what we are going to do is left score equal to left plus current. Okay, so for example, if we have like this and we got a path to get to end, so for example we have to add the current value to the left. So basically what we are doing here is we are summing up the current value from the left value if we had any valid path. Okay, so if we doesn't have any valid path, there is no point of summing up, it's summing it. Okay, the current value. So we did for top. Similarly, we are going to do for left. Similarly, we are going to do for, I mean, top left. Just we have to repeat the same part of code. Simply is returning. I mean, instead of I minus one, we are going to do j minus one, and in diagonal top left, we are going to do both I minus one and j minus one. Okay. So for top left is I minus 1 and j minus 1. And after doing I minus 1, j minus 1, so after getting left score and left path, right score, right path, I mean top score, top path, top left score, top left path, we are simply going to calculate the maximum, and at last we are going to return what the max score and max path, the number of ways to get that max score. Okay. So now I think let's write the code. Okay. And n equal to board dot size auto score comma ways to get that score equal to DFS starting from n minus 1 n minus 1. So we have to start DFS from bottom left, so bottom right, so that it our starting comma to pass the board also, and at last return the score comma ways. Okay, so that's the code, and just write the DFS. So the basic DFS, so we have to return the pair. So our DFS is pair type. DFS, the parameter we are taking is the I int j vector of a string, yeah, boards, or pass it by reference board, and after that simply if if the board of I j current cell equal to end ma e, we are going to end up return E basically means we have reached the end, so we got zero score, and number of ways is one. We have one ways to get that zero score. Okay, and after that we have to do int of se of score equal to zero, of path equal to zero, and left score equal to zero, left path equal to zero, and diagonal score equal to zero, diagonal path number of ways to get the diagonal, and number of ways to get that score is also zero. And after that simply, okay, let's extract the cell for now. So del equal to the I j and get the current value. Current value is if del equal to s, if we are at a starting point, the current value is actually zero, and if we are not, is question mark here, if we are not at the starting point, so the current value is character, I mean this cell minus character zero. Okay, character zero, and after that simply move up left. Okay, so for now move up So to move up, first check if up is valid or not. Okay, valid. If it's valid, I minus 1, comma j, comma. We have to pass board also. Okay, okay, let me write quickly the valid function. Boolean valid int I int j. Okay, int I int j and vector of strings. Vector of strings called it. I mean, it's board our board and return. So to be valid, first of all, I greater than equal to 0 and j is also greater than equal to 0 and I is less than n. J should also and j should also less than n. And one most important thing is board of I j should not equal to x. Okay, so there shouldn't be any obstacle. And you have to get the end here. So int n equal to size of board. Okay, so that's basically our valid function. And here, so let's get the score and ways to get that score equal to score and ways to get this score we are going to get from DFS doing DFS on the upper cell. So upper cell is I minus 1, I minus 1, comma j, comma BOARDS board. Okay, and so basically up score equal to score of path is equal to number of ways to get that score. And if we got any valid ways, okay, any valid path to, if we get any valid path to get score, whatever the score is, simply we are going to do is, I mean, up score, add the current value, FPORE, add the current value on the up score, that is CURR. Current, okay, so, and we have to repeat the same code for left, for diagonal, and in top left. Just we have to replace the variables. Um, so for left scope, for the diagonal scope, that's for left path, that's up path gonna become left path. For diagonal paths, so up path gonna become diagonal path. So I think yeah, we pretty moved and just get the, and the final thing we have left with is get the maximum. Okay, so max score equal to maximum of up score, left score, and diagonal score. Okay, up score, left score, and diagonal score, and and number of ways to get that score, get that maximum score. So max ways, you can call it max ways. For example, it's 0, and if max score equal to up score, so this basically means we have can add the, I mean, max ways, max ways plus equal to the up path. Okay, just copy this And if we got max score from left score, we have to add the left paths also. If we got max score from tag score, we have to add the diagonal path also. And after that, simply return the pair of max score and the the max ways to get that max score. Okay. And I think yeah, that's it. So if we run the code, yeah, we also forgot to do this j minus 1, I minus 1, j minus 1. And now if we submit the code and see, yeah, it's working. And if you try to submit this code, it's basically I don't think so. It gonna work here. Time limit exit. So simple ways to get rid of time limit exit in recursion is memorizing this code. So we can create a vector of 2D. Okay, we can create a vector of int type. Actually pair type. We have to return a pair. Okay, let's call it memoized. So what we are going to do is we have to check here if and initialize it by -1. Okay, and I'm going to initialize everything with -1. So if memo of I and j, if you already memoized I plus j, so that if you memoized I plus j, so that is not equal to -1 dot first. Okay, so it's code r f I r s t dot first not equal to -1. We're gonna return the memoized value. Okay, and at last, okay, and yeah, that's it. Okay, first assign the size. Dot assign and comma vector pair int of size and everything wanna is to -1 comma 0. So there is 0 ways to get the -1. And now I think we have to do it explicitly. Yeah, got it. So instead of doing this, what we can do is max w max ways plus yeah. Now remove the code. Yeah, okay, now it's worked totally fine. Okay, so I think yeah, that's it for today. And if we want to discuss about the space complexity and time complexity, so space complexity is big of n square because we are using and we are memorizing at every possible value of I and j. Okay, and the time complexity is also big of n square. You might think the recursion gonna end up taking more time, but the reason that's why the reason we memorize that. Okay, so if we are if you visited here and if we are again visiting this index, so this is already stored in our memo, so it actually directly gonna return instead of visiting the whole path again. Okay, so I think that's what we did by sacrificing n square. Here we actually reduce the time complexity, so kind of n cube. Okay, from n cube we actually reduce it to n square. Okay, so here in our final code, the total space complexity and time complexity of our code is big of n square. Okay, so I think Yeah, that's it for today. I hope you like this video, so please make sure to subscribe to TENZOR and feel free to ask any doubts if you have in comments, and till then keep smiling and keep coding.